The preparation of a standard base lab experiment is the first experiment this semester where we get to perform a titration. And the purpose of this titration is to standardize a base. In this case, it's going to be sodium hydroxide. There's going to be a solution of sodium hydroxide already prepared for you. You're going to get about 750 milliliters of that in a 1 liter bottle, and that's going to be yours for the semester. But you need to figure out the exact concentration of this solution. You want to get 4 decimal places, and you want to know a little bit about the error in that measurement, and including some standard deviation measurements, or calculations to be exact. So the way we're going to standardize the base is we're going to use KHP, potassium hydrogen phthalate. Okay, this is the phthalate ion, this part here. And there's your potassium ion. So this is a salt that readily dissolves in water. It's got a high molar mass, and it can be dried very easily in an oven, which makes it a really good salt for determining or making a standard, in this case standard sodium hydroxide. So it's an acid, so when we add sodium hydroxide to it, we react as an acid with the base, and we produce water and salt. So to get to the details of what you're going to be doing in lab, this experiment's a little bit different. You've probably already titrated with done an acid-base titration. Maybe you've even standardized base before. So what we're going to do is have you follow a protocol outlined in the handout. We're going to have you follow that exactly. And we want you to do that 3 times. So you can get 3 good titrations following this protocol. You may need to actually do more than 3 titrations in order to get 3 good titrations. But in any case, you need 3 good titrations. And from that, you're going to determine the range of the formalities determined for your sodium hydroxide. And to get full credit for this experiment, the range needs to be no greater than 0.0005 formal. So you've got to be really good in doing your titrations. If it's outside of this range, you're going to lose some points in your lab report. So you follow this protocol exactly, and you do that, you may get 3 good titrations, and you have a range that's within 0.0005 formal. The one thing that you should note is when you calculate your formality, you need to adjust for the temperature. So what this means is that we may be doing our titrations at 25 Celsius, and it's possible, given the air conditioning in the lab room, that temperature fluctuates slightly during the lab period. So you want to make sure that you adjust for the temperature so that it's all the titrations have essentially occurred at the same temperature. So in order to do that, it's just a ratio. So the formality at temperature 1 over the formality of temperature 2 is going to be equal to the density at temperature 1 over the density at temperature 2. And we're going to use the density of water because the concentration of sodium hydroxide is so small that it really doesn't affect the density of the solution that much. And the main thing that's going to matter is the density of water. So there's going to be a density of water table hanging up in the lab. You can also find this online. And so we want to standardize our formalities to 20 degrees Celsius. So you can plug in, solve for the formality at 20 degrees Celsius, given the formality at whatever temperature you've actually measured, using the density at 20 degrees Celsius and the density at whatever temperature you've actually measured things at. So this is a ratio. So when you do this calculation, you want this results of the formality at 20 degrees to be within this range, okay, 0.0005 formal. So once you've done that, you're going to discuss this protocol with your neighbors. And you don't need to form a formal group. All of these titrations that you're going to perform are going to be done individually. But we'd like you to talk with a neighbor just so you can bounce some ideas off of each other and compare results for the next part. So you're going to pick one part of the protocol that you thought maybe not necessary. So you had to dry some hydrogen, dry the KHP, you had to boil water and use a certain indicator, things like this. Come up with one of these parameters that you want to test, you want to change. Maybe you don't want to boil water, maybe you don't want to dry the KHP. And so we're going to do another set of titrations. Where you test your you test whether or not one of the parameters in the protocol, one of the steps in the protocol is necessary. And so your titrations in this part, they don't have to be within a certain range. You may find that there's a large standard deviation or a large range in these measurements, and that's okay. What you're going to do after you've got your 3 good titrations following the protocol exactly, and your 3 other titrations changing one step in the protocol, is you're going to compare statistically the results. So you're going to do some stats. Okay, you know, whatever statistics you need to do, it might be a t-test. And in order to do a t-test, you're going to need an f-test. And you want to see if the results from the eliminating one of the steps of the protocol is the same as the results following the protocol exactly. So, do the results agree? So that's one of the main things you're going to be answering with this lab experiment. This is a 2-week lab. So the first week, we want you to follow this protocol exactly, get your 3 good titrations in, adjust for temperature and things like that. The next week, you're going to do the 3 titrations, changing one step in the protocol. So, like I said, you can talk with your neighbors about changing this step. You can also share data if you want. You don't have to, but if you do share data, you need to cite your source. So you need to give your neighbor credit. Now, if you share data, you still need to have your own 3 titrations. This is just if you want to have more data in addition to that. Okay? No requirement for that, but it is something that some people like to do.